Hi guys, here's another video about the CSS Pure Mathematics Exam from 2023. This is section B, question 5, item B. It asks us to evaluate the double integral of the function x squared plus y squared over the region bounded by y equals x squared and x equals y squared. So we have these curves and we will first sketch the region over which we want to integrate. So here are the curves, y equals x squared, this parabola here, and this is the curve x equals y squared, this other parabola. And we can, as we can see, they intersect at 2 points, and the region bounded by the curves is this gray region, which I called R. So this is our region of integration. So now let's find the points at which the curves intersect. So we can take, for example, we can look at the expressions which define the curves. So we have y equals x squared and x equals y squared. We can substitute, for example, this y here for x squared, and we obtain x squared, x to the power of 4 equals x. So now we can solve this equation. It's not hard because x to the power of 4 equals x is the same as, it's equivalent to this expression, x to the power of 4 minus x equals 0. Now we can factor this polynomial this way, x times x minus 1 times this polynomial x squared plus x plus 1. It's easy to see that this polynomial here has no real root. So for every real number we put here, this will never be 0. So the only way this whole expression here is 0 is if we have x equals 0 or x equals 1. So the points at which the curves intersect are 0, 0, because the points must satisfy, for example, y equals x squared. So if we take x equals 0, we get y 0 equals 0, so 0, 0. And if we take x equals 1, we get y equals 1. So the points at which the curves intersect are 0, 0, and 1, 1. So now we are almost ready to integrate. Now we need to describe this region by using some formulas which will allow us to integrate. So we are going to describe this region in the proper way which will allow us to make the integration we want. So observe that if we fix some y between 0 and 1, and we take this horizontal line y equals y0, this line, like if we look from the left to the right, this line, it enters the region at this point here, and it exits the region at this point here. So for example, since the y equals y0, and we know that this curve here is the parabola x equals y squared, at y, when y equals y0, x must be y0 squared. So this point here should be y0 squared y. And on the other hand, since this parabola here below is the parabola has the equation y equals x squared, since the line is y equals y0, when we have y equals y0, we must have x equals the square root of y0. And these are the points, the entering point and the exit point. So this way we can see that the set of points, this line segment here, which is contained in the region R, is this one, can be written this way. So it's the set of points. We must have y equals y0, and x goes from y0 squared to the square root of y0. Okay, but this can be done for every y0 in the interval 0, 1. So this way we can write R in this way. So we can express R as the set of points in R2 where we have y greater or equal than 0 and less or equal than 1, and x ranges from y squared to the square root of y. So this is the description of the region. Now we are ready to integrate. From now on, we only make calculations. So we can write, so since the function we have x squared plus y squared is continuous in the whole space R2, in particular it's continuous in the region R, and we have that the integral we want to calculate can be written as this iterated integral. So we have, since y goes from 0 to 1 and x varies from y squared to the square root of y. So now we make calculations. So first we have to solve this interior integral and then the outside integral. But this is easy because x squared plus y squared, if we integrate this with respect to x, we get x cubed over 3 plus xy squared. And since we have the integration points here, the extreme of integration are, the limits of integration are y squared and square root of y, we just plug them here and we make the substitution. So we get this. So it's easy to make it. The calculations are not very hard. Now we are going to simplify this a bit because we can write the square root of y to the third power as y to 3/2, and we can write the square root of y times y squared as y to 5/2. Now we integrate again. Now we just have to integrate with respect to y. Again, it's easy. We are only integrating powers. So we get this expression here, and now all we have to do is substitute 1 and 0 and take the difference. So if we plug 1 here, we obtain this. If we plug 0, we get 0. And our final answer is 6/35. And this is our final answer. Thank you very much. I hope you enjoyed this video. Please give me a thumbs up, subscribe to the channel, and please share the channel with your friends. I hope you like these videos. Will post the next in a couple of days. Thank you very much. Bye.